Hello. Yes, we welcome you back to PSSB, Physical Sciences. Silver Bullet with me, Richard here. Yes, today we are looking at this question. It says that consider the following. 1, ammonia solution, and 2, aqueous sodium hydroxide. And then the question says that write the equilibrium equation representing the dissociation of each. Okay, let's start with ammonia solution. Okay, this is it. This is ammonia. And let's assume it is in water. Okay, so what happens here? What happens is that ammonia has a tendency of accepting a proton. So it accepts a proton to become ammonium ion. So losing a proton, what remains behind is OH, ions. So yeah, this is the equilibrium for dissociation of ammonia. Actually, this is not dissociation, it's ionization of ammonia. Yeah, then we come to aqueous sodium hydroxide. Okay. Aqueous meaning dissolved in water. So what happens here? This one is represented in this manner. We have sodium ions and hydroxide ions. Okay. Yeah, you have to take note that in this case, our equilibrium is in one direction. We use a single arrow. Why? Because sodium hydroxide is a strong base. And how do you define a strong base? Is the one which is fully dissociated. So it means that we are representing it with an arrow in one direction. So these are aqueous ions, and that is it. Yeah, then we come to this question. It says that write expression for the base dissociation constant Kb for ammonia. Yes. Okay, how do we write this? Okay, you have to know that this is the same equilibrium constant which we know. So it's going to be product of reactants. So it's going to be concentration of ammonia, ammonium ion into concentration of hydroxide ion over a concentration of ammonia into concentration of water. But you need to know that technically water remains unchanged. So if it remains unchanged and doesn't undergo any change, we leave it out. So our final expression is going to be Kb giving you concentration of ammonium ions into concentration of hydroxide ions over concentration of ammonia. Yeah. So what you have here is the Kb, or base dissociation constant for ammonia. Yeah, then we come to this one. It says that compare the base dissociation constant of ammonia solution to that of sodium hydroxide. They said write higher, lower, or equal. Yeah, the answer is lower. You have to know that we are comparing ammonia to sodium hydroxide. Yeah, then we come to this one. It says that explain your answer above. Okay, our answer is lower. What does it mean? That the base dissociation constant for ammonia solution is lower than that of sodium hydroxide. And why? What's the reason for that? The reason is that ammonia or ammonia solution is a weak base, which is partially dissociated, compared to sodium hydroxide, which is a strong base, which happens to be completely dissociated. Yeah, that is it. Yeah, now we come to this one. It says that compare the conductivity of sodium hydroxide to that of ammonia solution and explain your answer. Okay, what are we doing? We are comparing sodium hydroxide to ammonia. And what's the answer? The answer is higher. Sodium hydroxide has a higher conductivity compared to that of ammonia. Why? What's the reason? Yeah, the reason is that sodium hydroxide is a strong base, which is completely or fully ionized, compared to ammonia, which is a weak base and so partially ionized. Yeah, that is it. So here we need to understand that because sodium hydroxide is fully or completely ionized, it releases large number of ions, which makes the conductivity to be higher. That is contrary to ammonia, which is a weak base, so partially ionized, so releasing fewer ions for conductivity. Yeah, so we come to this one. It says that compare the rate of reaction of ammonia to that of sodium hydroxide and explain your answer. Okay, we need to know that we are comparing ammonia to sodium hydroxide. So what is it? Is it higher or lower? The answer is lower. Okay. And what is the reason? Yeah, the reason is that ammonia is a weak base, which is partially ionized, releasing fewer number of ions, compared to sodium hydroxide, which is a strong base and so fully ionized, releasing a large number of ions. We need to recall that concentration is one of the factors affecting the rate of reaction. And the lower the concentration, the lower is the rate of reaction. And with that, I would like to thank you for your time. The channel is PSSB, Physical Sciences Silver Bullet with me, Richard here. We urge you to subscribe, to comment, to like, to share. Yes, we believe we are the best. Stick with us. You won't regret. See you next time. Bye bye.